when you're something that's hot, yes?
Yeah.
And they say the most energy is vibration, energy, blah, 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 yes?
Mm-hmm.
So when you drink something that's hot,
Yeah.
and you feel it go down,
Yeah.
is it because you're feeling its vibrations? Because the hot drink, even though it may not be hot,
Mm-hmm.
unable to drink it, isn't it still jostling around?
Yeah.
So therefore, if it is still jostling about, is that why you feel it in that first instant? And then the body cools it down,
Mm-hmm.
if you want to say it that way.
Yeah.
It doesn't really technically cool it down to cold.
Yeah.
It just resonates it with your 36 or 37 degree temperature. And when you feel it in a resonation, in that sort of resonance, I should say, then you no longer feel it.
Yeah.
And then if you drink something that is cold, very cold, you feel it in the first
As
moment,
well.
in the first
Yeah,
instant.
yeah.
Now is that because it's still? It's not moving as much, therefore it's not resonated with the body when you drink it. So the coldness then has to be warmed by the body, and the body begins to warm it, and then the drink starts reverberating at the same frequency of your overall frequency, because if we're 36 degrees, we're jostling around, aren't we? We definitely are.
Yeah.
And then this poses another question. Is light sound and sound light? Think about it. And if it is there a feeling or a sound being emanated from the light?
Maybe.
You just can't hear it. And then in the darkness, the cooler, is there a sound? Is there a feeling that we would interpret as this? Would we say that this is making a sound? If it's jostling and you can't hear it, is that because you were born into it? So you were born into light and dark, light and dark. How do you not know when you were a baby you weren't hearing the differences or feeling it? It depends on them hearing and feeling, and I can't tell the difference between the two, really. I think that feeling came first. Feeling, if we evolve backwards, and let's say if we could reincarnate with capturing the memory or the essence of all your memories, and you could remember the first time when you evolved into humans, if you could remember all of those existences, stockpile, I mean, that's a lot of knowing. But if you could, some weird way, let's say life forms on another planet, perhaps they have this capacity to understand reincarnation in a way that is far more, maybe humans never got it, but perhaps these ones had a different way of evolving that led them to, when they died or transitioned through family member, and then they grew, I don't know, let's just go out of the box that when their kids had a kid, they were then transitioning over into the child, let's say, and then that knowing was retained, and oh, I'm that person, but now I'm this person, and they remember all of the things. I mean, it would be quite bizarre to think that, though, wouldn't it? But if they could remember that, would they have gone back enough to understand that feeling was the first thing, before ears or hearing? And then feeling got a bit more designed, let's say, a bit more evolved, and then to a new type of feeling, but with hearing, associating a type of sound. So that is it then that the body has been, oh, hang on a minute, there's something else talking out here on that feeling with no ears, no receptors for that. Is there something going on here? The same way with light, right? Were we all blinded in the beginning? Couldn't see and couldn't hear. But then as this kept impacting the skin, perhaps, this pushing or this heating and cooling, and perhaps to understand that world a little bit more, to evolve, to help you evolve. You think about it, if we were reptilian, and we got reptilian part of the brain, which is it? Did a reptile and a monkey ape breed together and then create humans? I mean, very bizarre, right? It's a weird way to think that you've got reptilian and then, well, no, because they evolved from, but yeah, where did it fork off? That's the thing. And then if we are reptilian, then you could say that we were feeling mainly in the beginning. Feeling these hot and cold spots, but perhaps the brain needed some help with evolution to be able to see what is causing this hot and cold spot? Why does it get cold? Oh, there's this bright thing up here. Okay. And we did bask in that. And then what came first? Was it feathers or was it fur? You know, to answer that, that's another one. That's interesting. And then what, the evolution of lack of fur? So how does that all work? Was it everything was feathers, then turned and transitioned into fur? Then fur was probably not great at the environment, so then let's go to bald-ish. We kind of are. And then as if it's related on how hot the climate gets, colder the climate.
Yeah.
No, reptiles don't fare very well if we have a ice age, really, would they? I don't think they would fare up very well.
No, they didn't, did they, in the past? Although they died out before any ice age. The ice age came and removed the rest, the smaller ones probably.
To a degree. Maybe some evolved with fur.
Maybe.
This kept them good. And the climate got hot. And you evolved to have lack of it. Interesting. But still, again, we're drinking the drink is the main one.
Yeah, and if it's very hot, you feel it really like nearly pain. If it's warm, you just feel the difference, sort of. And when it's very cold, it's again like...
Do you feel temperature if it's perfect?
I don't think so, no. No, we don't.
So it resonates?
Even in mouth, doesn't it?
So there could be a lot of things going on in the environment. But would we ever know they existed if they stayed in a perfect frequency? With you, the body, the human.
No, we wouldn't.
We would never know. Yeah. Unless there was fluctuating. Isn't that interesting? Yeah. But there again, the earth rocks back and forth. Don't feel it. Shades of grey on that one. You don't feel it right now. So then does the earth resonate with the human body then? Is that movement the same sort of resonating, jostling that is resonated with the human body right now? Have we adjusted to that resonance, or
we are resonating with it? It's not resonating with us because we are smaller, isn't it?
I don't know. Things that are smaller have more resonance, don't they? And then you've got a sort of frequency that goes on within the body. Everything seems to be doing everything in synchronicity. So is there a synchronicity? I mean, if we were to imagine the Earth spinning, if a meteorite clips it, I hate clipping meteorites. Those ones, but I don't know. Not something that I really am keen on experiencing.
But you told me that you felt earthquake, haven't you?
A feeling, yes. When the earthquake happened in 2007, I believe it was, I was hankering Amy and Kerry for the whole day, and then Chris came over and asked, "Man, do you not feel? It was I could hear and feel something, but I couldn't hear it. It was more like an internal hearing, and this sort of grinding sensation. Something was amiss. So I was quite sensitive to that. Yeah, that was...
That's like being out of sync for a bit, isn't it? Because it's different.
That is a good way to explain that.
Yeah, I had that feeling too, and it was not very nice.
And then that's then what led me to understand what animals picked up. Yeah, I get it. It's subtle though, but it's not, but it is. And there's also a sort of bubble in the mind occur. How to explain that? Like we have a gyroscope in the mind, yeah? That's the only way I can explain that. And it got a little bit... It wasn't aligning properly, that particular... I don't know, it grew over some time, actually. It wasn't like it was just that particular day. It was the strongest on that day. And because I hadn't experienced that while human, I'm going to have to say it like that because, you know, as far as I'm aware, it was so out of the ordinary. That's something knocked my gyroscope. Feeling, if you want to say like, and it was enough to make you want to go inward. It brought more awareness to the inward thinking.
Mm-hmm.
Not that I needed any help with that, but there was something, and I couldn't put my finger on what it was. It was a bit like before you get an intense storm. There's that sort of head pressure.
Mm-hmm.
In something is just not normal. No, I don't want to say not normal because it is normal because it's a feeling. I can't say I could get it right every time, but that particular time I was very sensitive of it. Now, whether it was due to the building that I was in at the time, because what is that, like 400-year-old? I don't even know, 200-year-old? I'm not sure the age, but it's old. I wondered if it had something to do with this. Perhaps it's the way it was positioned or the old boards. But then when I woke up early hours of the morning with that, something woke me up. I don't know what it was. I was awake. And I just was, okay. I just didn't feel quite, I didn't feel strange. I didn't feel ill. I just didn't feel right. And then all of a sudden it started. And it was almost like an inner thing was like, oh, by the way, now. And the doors were making quite a lot of racket. I mean, the thing was really swaying. And, yeah. No, it's just like, oh, this is pretty awesome. And I was like, hey. Everyone's like half-ass asleep, right? I was like, there was an earthquake. They were like, yeah, right. They all slept through it. I was absolutely amazed by it, right? You got a house full of people, and I was just like the only one that shared this experience whilst they all slept. Oh, well, I was really having a good time in that moment. And I think because of that, it lasted it felt like it lasted quite a while. So, very interesting, sort of. There's a certain amount of feeling or hearing. Feeling, it's neither of them. It's in between both of them. Like some sort of sound that you just, hertz frequency that is probably low, but it's not at a constant pitch. It's an up and down one, I think, peak and valley. Yeah. Again, like with the planet, you don't feel it. Perhaps in earthquake or different things like that. But if a meteorite clips the planet at just the right angle and causes the planet to increase in its rotation. Now, let's hope it doesn't increase too much. And it's a weird experience that will happen. Most of the people who are elderly will not cope with that very well. The young will be able to cope with it slightly more if it doesn't hit and cause it to spin too fast. If it spins too fast, you'll be pinned to the planet.
What if it spins in different direction because it hits in different direction?
It would strobe.
Instead of this way, or...
If it created a centripetal force. I'm not sure many humans would cope with it. The spinning and the rotation, and you will then know what it feels to have to... You see, I think the planet, either if it speeds up, let's say it doesn't, but let's say if it slows down, it's slowly. It's very slowly. And it slows down slowly. And I think that we sort of resonate with that. So we don't notice it as much. But if it's slightly all of a sudden increased, I don't know. No thanks. The strobing of the light dark from the sun. If it goes too fast, I don't think it will be like strobe. And moving will be quite the thing. You won't realize how much you rely on a lot of stuff when trying to move. Babas, toddlers that transition from baby to toddler, will cope with it. But it's getting them through that. The transition, and there is a very small number of the population that will be all right with that. That will become their new resonating, if you like. They will resonate
How
with
about
that.
some animals? What animals would?
Not many.
Bugs?
Oh, it has quite big and then again, if it smacks at the bottom, not all of it is completely vaporized. It depends on how big it is that hits you and where it hits, because it's not just Earth that flies off back out into space and rains down. It's also animals. You see, I'm surprised with the amount of meteorites that have hit the planet. How we haven't found any fragments. Again, some of it can be pushed away far enough to go elsewhere. It's not impossible for it to be some fragments to be on the moon. Mars, again, it depends on how fast they're traveling at the time. Not to get too vapory. Moon, probably not so. But compacted in that dust somewhere should be some life forms from Earth. Past ones. And it depends where it hit, how it hit, what the consequences were at the time. You can run away with that. There would be quite a bit of prehistoric. It'd be interesting though, but I mean, it would explain away if you ever found anything odd on the moon and be like, oh my god, there must have been life here at one point. No, I don't think so. I think the life was knocked. I mean, what about if you knock a bunch of water off? I mean, is it impossible? No, I don't think it is. When we're talking how fast some of this can go, and what it hits and collides with and knocks into another piece that pushes, it's not impossible. The moon especially, looks like it wasn't always orbiting. It looks like it travelled, if you like. It's called potted. You never know that in that movement, with all of that constant potting, you notice the dark side of the moon is very cratered.
Yeah.
But the front, not really. You can also slow down bodies by it hitting into lots of debris, and then it starts to slow down. So, if you had a rogue moon or a rogue planet, depending on what it was colliding with over the long distances, it would slowly but surely begin to slow down. If it was traveling really fast in the beginning, depending on what it hit into, especially like the Oort cloud, if it crashed into a load of that, it would pop one side. Perhaps it doesn't spin while it's traveling, and then this could slow it down. I mean, that would be a strange fluke, right? And then it got caught in Earth's gravitational pull, if you like. And then perhaps the orbiting process started with a few more that hit it and caused it to rotate. Very interesting, really. But that's when you would get an odd, very looking sort of celestial body, if you like. Yeah, one side of it will be potted, the other side just look weird. Just look very, very strange. But it can collect a lot of... you see, if I was to ever go to the moon, I think my interest would be on the opposite side of the moon. It's not technically the dark side, because I think the moon orbits at just the right sort of ratio in order to always face Earth the same way. But the back end of that, if with all of these pictures to be accurate, I'm not saying that they're not, then those impacts on the back there hold significant, I wouldn't say clues, but better understanding of the origin of the moon and a lot of treasure for humans, let's say. There would be a lot of strange stuff in that. If you could blow away the dust and you could get down to that, there should be some interesting stuff there. Stuff that would throw your belief of where the hell did all this come from? That a lot of meteorite craters hold much value to human. Nearly all of them. Nearly all of them.
Why?
Because of how rich in different stuff that they have collected. Remember, meteorites get a bad rap. They really do. But they bring an awful lot of goods with them. Especially if you've got one that's come from, let's say, our closest star.
Mm-hmm.
Something has jostled around in there and knocked a few out towards the sun.
Mm-hmm.
Well, it doesn't hit the sun, but it hits the earth. Well, it's just brought a piece of difference to you. And if something's hit you and knocked it out, you've brought a piece of difference over there. So, sure, if it was formed in a different nebula, and this one is formed in a different nebula, yes, different composition. Each nebula holds different, slightly different ingredients. This cake is, yeah, it's going to make planets, yeah, it's going to make stars, but those ones are going to be cooked up in a different way to what this nebula is going to cook. So yeah, you've got flour, eggs, and sugar in this one, but you've got flour, eggs, sugar, wheat, and let's say a few gravy granules in this one. We're making some bizarre cakes right now. But let's say this one didn't get those gravy granules, right? Because they weren't in the clouds, let's say. Then something happens over here that knocks a few of those gravy granules over and it rendezvous with the Earth or orbits around. You have just brought a piece of that universe, solar system to you. This sharing of ingredients like this is more common than I think we care to understand, let's say, and especially when the stars in the galaxy are moving up and down with one another, yes? Yeah, Earth seems to, with the sun, seems to lift out and then come back down. Well, when it gets closer to another star, its Oort cloud and its Oort cloud interfere with one another, that they could, at the right time, at the right sort of rotational rate. I believe that most of it is rotating anyway. Some of it isn't, some of it is. But when they get knocked via gravitational influences, so perhaps the star is not just up and down, it's also slightly wobbling. And this one is also slightly wobbling. Sometimes it's more further away. But when this one wobbles too close to each other, they might just swap ingredients. And it's like playing snooker, right? Or pool. And you've got them lined up in a triangle, and then you go to take the white ball and you smack it into those, and it knocks them in all different directions. Well, when you get one knockoff hit into another one, and maybe it sends one down here, boshes into this one and brings this one up, it's quite a mixing process, to be honest. And just because planets have formed, the mixing process is not finished. The building is not over until the star is over, and even then, its ingredients are passed on and other ingredients rendezvous with these ingredients and perhaps go on to make other stars with different composition. I think each star slightly has a different composition to the other, and another galaxy holds a different composition. And then when you look at the black hole in the Milky Way, it's got a little small one that's merging with the larger one. Let's say they like to cannibalize each other. I don't think they cannibalize. I think that's a very strong word, to be honest. They like to unify and become bigger, hold on more stuff. They seem to unite in a way. Stars unite in the beginning and at the end, but not during. They tend to like their distance. They tend to like their space a little bit. Just want to be over here because it's in their best interest. Because the matter just seems to not be able to... stars create matter, yes? They take stuff and put it in together. So let's say they take a gas then, and they then begin to make matter. They fuse things, is what they do. But it's almost impossible for them to fuse each other together. Not impossible, but it seems less likely to occur that way. That type of the evolution is not there. Whereas black holes defuse, they take matter and revert it backwards, but they can't go past zero, and stars can't go beyond it. That's interesting, isn't it? They can plus it. whereas black holes minus it. And with this, in this minusing, they learn to integrate with each other, whereas stars tend to like their space. Black holes seem to blow together, in my opinion, and stars want to die on their own. Kind of odd, but it's how it is. And when they try and get too close, they siphon off of one another, and it just gets very, very complex. And usually it doesn't end well for all stars involved, because when one pops too close to it, the other one is usually knackered too from it, to be honest. Not all the way till death, some of them, but significantly damaged enough to halt the process down a lot, and it just doesn't bode well for any life forms that are in this situation when two stars get too close together. It's not great. Mm-hmm. So when we look at that black hole, we see a slightly smaller one trying to merge with it. And this is just what they do. But this black hole has brought ingredients from another galaxy it's had around it, and it's brought this new medium into the mix. And now, I mean, you've got to think about it like astronauts, okay? If I got a group of astronauts that go over here, and go over here, and go over here, and they bring back some moon rock, they bring back some Mars rock, they bring back some of Jupiter. Some of this is going to be slightly different cooking ingredients and different cakes, pieces of crumb of cake. Don't you think that that's a long way to do it? Now, let's turn it on its head, and now we bring a galaxy from over here with its ingredients. So far away that those ingredients are slightly different. This has evolved from a very different way to this one has evolved. It's kind of like lots of little mini cakes that make up one, and these ones have lots of other different cakes, and they bring it over here. Yeah. I think life forms that get ahead get lots of crumbs from different areas, and then their knowledge begins to increase with more that they get, because the more understanding. Well, I thought I'd seen it all, but what's this new material? I've never seen this before. Oh, bloody hell. Shift again, shift again, shift again. And then what? The amount of time that they're with this new material, what does it do? How does it affect them as a life form? How does it affect their nature, if they have any? How does it affect the growing in that? Then they study it and its effects, and is it beneficial? Is it detrimental? Is it toxic? Is it a medicine? Does it help? Is there a gas over there that when you breathe it and mix it with your version of oxygen and hydrogen? Wait, it is, yes. And you add this new ingredient into both of these and you breathe it, it makes you live longer. It alters an evolutional process inside. Perhaps you've got a receptor in the brain somewhere that's been empty. No idea what that receptor fills, but then when you bring this gas, it fills in that receptor and it makes you superhuman of what you are. Then you would understand that that's a beneficial. You can have another one that you bring in and it jumps into a receptor and that's it. Mm-hmm. Okay, well, these are a maybe then. Yeah, and there you are. But again, if it does jump in there and it does cause instantaneous death, it's not the end of it, because introduce it slowly and minimally might, it's risky, I wouldn't, but again, might be able to fill that receptor, but at what cost? And then what is the outcome? Because remember, if the body has experienced new stuff, it can evolve with these new ingredients too. And therefore, you evolve differently if you're on a different planet, if you're in space, if you're this, you will change. So if you're out in space and different things, and astronauts quite rightly say when you watch them moving through different areas, the legs just become, I don't know, if you had some robots on there with some grippers on it, and you could control these with subtle movements and send a signal down, and it then grabs hold of and acts like another pair of hands, perhaps the feet become useful. But other than that, they're more like dead weight. And then the bones will change and different things like that, and the blood is able to pump more and this, that, and the other, and you might degrade in muscle material. So you become more of a space being. Well, if you stay in this particular environment long enough, well, of course, the body is not going to waste energy on making things that you needed to defy gravity. No, no, no. It's going to use that energy. It's going to save it, and it's going to transform that energy into growing into something else. Perhaps we would look like sort of spiders, right, with hands and arms, and another set of hands and arms, because these would become more able. So you'd look like a sort of spider, torso-y spider, right? And then when you then rendezvous, let's say you're traveling in space for a very long time for that to happen. I don't think it would be that long, but the energy that was then gone on the legs would then transform into something else more needed. Yeah. Weird the way it works. And then when you rendezvous with a planet with gravity, again, it would have to be minimal. You would then have to learn the gravity. Mm-hmm. And then, these might not be so good anymore to have this many. So something new would have to come out of that, that energy once again. Yeah, I mean, the body is amazing, although we see it not change very much. Well, we do in terms of height. Some of the younger generation are more taller. Yeah. But this could be to remove away from the carbon layer. You get a bit more taller to reach the sort of happy medium area of not too much carbon and not too little. You do need it, just not in a large amount, if you get what I mean. Oxygen in higher ratios can be quite detrimental. So it's kind of, there's a fine line between it.
Yeah, it is.
So the height is increasing. Definitely when you look at the old door frames, you'd be like, why on earth is that? Well, you could look at pollution as an answer for that. You could. To grow a little bit more taller, a bit more taller, a bit more taller. Then you'd be like, well, so is that why the dinosaurs were so tall? It probably was. It probably was. Maybe it wasn't, but it could be. So, I don't know, just evolving. And if the environment has been tempered, interestingly uniform, inside a house the environment is quite uniform if you don't have a fan on. So the gases start to uniform, right? Mm-hmm. Carbon tends to sink, not 100%, but still, we've got radiators again, that's not very uniform because the heat rising and it just whips up a lot with it, so it causes this sort of jostling. But it's more uniform than it is outside, right? Mm-hmm. That's why you don't ever seem to feel warm in the winter, because it's all moving, right? It's just all jostling around, and it's more colder because we chip away, but still, inside a house it's far more uniform than it is outside. So the gases tend to uniform up a bit more. So carbon becomes an issue in that sort of environment. And then you've got more uniform heat across the top of the ceiling and more of a cold layer across the bottom. So if you have a fan on, it jostles it, it mixes it. But inside a house, it's more uniform. So things should less likely to decay inside a house than it would outside. It's a shell over a shell. And when you're in this environment a lot, you tend not to evolve as much because the body adapts to this uniformed environment rather than the ever-changing outside. So we lose a lot of oil on the skin these days. Sometimes we produce too much, but if you're outside a lot, you might find that this is more of a barrier. The feet are no longer as hard anymore on the bottom of the feet. Mm-hmm. But if you spent time barefoot and outside, walking around, the feet would become very hard. Mm-hmm. And you would be able to walk over things that someone who was in a uniformed environment might feel that would hurt a little bit more. Yeah? Because the body has, I don't need to do this anymore. I don't need to add this extra layer of skin. And this energy might be going into something else. You don't know that. That's why I like the nail idea that since we've stopped digging in nails in soil and stuff, we often think to keep our nails and underneath our nails very clean and stuff like that. But we forget to realize that we absorb minerals, not just through the mouth, not just in the air we breathe, and parts of it get into the throat. The throat is very wet, yes, so if you're breathing in particles and the nose hair doesn't catch them all, it lines the liner of the wet stuff. So if you've got something that's wet and you flick a load of dust at it, it's going to stick to that than it is to something that doesn't have any moisture on it, right? You ever wonder why you swallow so much? It's to keep you wet. And this wet serves a purpose as a temporary backup. You don't have hair in your mouth, so when you inhale through the mouth, it sticks to these areas sort of first, if you like, before it gets to the lungs. So it just sort of keeps a little bit more out of the lungs. And then you swallow. And then this gets into the stomach. And there you have it. You have the environment that's just got into you in another way. But also in the nails as well. So if you're digging in the soil and you're in rich, nutritious soil and it gets underneath your fingernails, well, your fingers are you're gonna absorb that underneath your nail. Have you ever got a piece of dirt in there and sometimes you wonder how it gets so far back in the finger? Well, this is putting minerals at the end of the day. Soil is mineral. I wouldn't say that it's great if you went and dug in some not so great soil, let's say, contaminated and all the rest of it. That's not great for you. You'll absorb it this way anyway. And if you're out in the rain, you're absorbing. The rainwater is collected, among other things, pollution and different stuff like that. But it gets bad rap, but not always. Some of the Saharan sand or dust, and then the rain washes this out and it gets on your skin, and your skin will absorb this. And again, it's brought another mineral into your skin. We tend to not do this so much anymore, so we're not absorbing as much mineral content as we used to, let's say indirectly. That's what we think. Even the sand in your eyes, like when you wake up in the morning, sometimes you have some sand or sleep in there. Well, again, it goes to show that the eyes are absorbing mineral too. I think the body makes use of this. Too much of it is not a great thing, and therefore, no, don't need this. The body is very amazing. I even think in the nose as well, the cavity of the nose. It just depends on what you're absorbing high concentrations of. When you're outside, it's a little bit of everything. When you're inside, oh well, it could be a mold spore, it could be a dust. Have you polished that? Maybe. You've put a chemical on it. Now, if it's dried out after a while, are you breathing this? You see what I mean? I'm not saying that it's all bad and all doom and gloom. One side of it has greatness to it and a detrimental side of it, and another side of it has greatness to it and a detrimental side of it. It's all about the sort of balance, I'd say, in that. Again, not much similar to the stars, that you get different ingredients that do different things, and you can do different things with these ingredients. But yeah, again, so this kind of ran on from, can you hear light? Can you feel it? Is light sound and sound light? When you think about it, and which one do you think came first? I think feeling was first. And this vibration or this hitting on the skin drove you to have receptors that needed to understand this more so. Not saying that you couldn't do it if you couldn't see very well, because you might rely on the nose a bit more. So we probably had more feeling and more smelling. Smelling drops down a little bit. The eyes take refuge, and so do the ears. And again, that's vibration with feeling. So I guess it's connected to here, so it's more closer to the central nervous system. Yeah. Again, touch, feel. And then that sensitivity of feeling drops down a little bit. So, and if things resonate with you, get to your temperature internally, again, uniform environment, right? Yeah. Much like the house is a uniform environment, yes? Yeah. It's uniform when you are out in the environment of constant change. The decay ratio is slower, and the decay ratio inside a house is slower. Outside, it's faster. If you let the outside get in the inside, that causes decay and infection and different stuff like that. It doesn't resonate very well. But when you drink a drink, and it's hot, and it's jostling, although you can't see it very well, it's all jostling, that's why it's so hot, right? And you drink it and you feel it, oh, that's nice, that's very good, and then the body resonates it to you, your core temperature. You no longer feel it. And then if it's cold, it's not moving as much. And then the body's like, oh, you drink it and you're like, that's so nice, that's so refreshing. But the body's like, oh my God, this needs to move more, right? This isn't moving enough. Let's get this moving, we'll heat this up. Let's get this right, reverberating at our sort of frequency. And then it begins to jostle at your frequency and there you are, no longer feeling. So, resonance. Interesting one. Anyway, I think I platted along enough on this video, to be fair, but there you are. Resonating.